This section covers absolute value equations and inequalities. We will solve both of them. When you're solving absolute value equations and inequalities, the first thing you want to do is isolate the absolute value, just like we did the radical. With inequalities, we have and or statements. They are compound inequalities, so you have two inequalities. If it's less than, it's and. If it's greater than, it's or. You'll set up two cases for inequalities and equations, and then once again, we will check for extraneous solutions. I would really like you to think about this instead of kind of memorizing the process as you go through this. For example, the absolute value of x, understanding that if x is equal to -5, then the absolute value of that is 5, and if x is equal to 5, the absolute value is 5, and that's why you have those two solutions. With the inequalities, it's a little bit more. You know, what numbers can you plug in for x that are greater than or equal to 5 when you take the absolute value? Well, obviously you can do 5, 6, 7, 8, and so on. But what about the other way? What about, -5, -6, -7, -8? I should have went the other way, but you get the idea. Okay? So these solutions will be from -infinity to -5, including -5, but we'll have a union and then from 5 to infinity. And this is an or statement. Okay? If the absolute value of x is less than 5, all right, well, we know 4, 3, 2, 1, and 5 as well. But also -5, -4, -3, -2, -1, and 0. So everything in between there, but anything larger than 5, anything less than -5 will not work. So these solutions include everything between -5 and 5, and that's an and statement. So think about that as you guys are going through and solving each of these problems. So the first thing here, we're going to isolate the absolute value, so divide by 3. And then you have two things that you want to look at. What two values give you 4? Well, 2x plus 5 could equal -4, or 2x plus 5 could equal a +4. Those are your two cases. So set up your two cases and then solve. And so I solved and got -1/2 and -9/2. And I did check both of them, and they both do work. We want to make sure we don't have any extraneous solutions. So another way to do this graphically, I showed you with radicals, I'll show you again with absolute value, is that, I'm going to show you a different method on this one though, that if these two things are equivalent to each other, alright, then we should be able to set them up in the calculator that way. So if you look on the first slide, I pulled up my graphing calculator and I put one equation as 3 times the absolute value of 2x plus 5, and the other one is 12. And if these are equal, as it says, I went ahead and changed my window. So when you go to your graphing calculator, if you look at the window feature, instead of doing zoom in or zoom out, you can always go to window, which is your second button there. And I changed my x max and my y min and y max so that the graph would fit on there. Knowing that it was at 12, I knew my y had to change there. And so once I graphed it, you can see that I have the absolute value one, but then I just have that horizontal line there as 12. So this line right here is y equals 12. And what we're looking for is we're looking for the intersection. Where does it cross here and where does it cross here? Those are my solutions. So then we go over to calculate. Last time we did 0 because we had set it equal to 0. This time we're going to do intersect. And so intersect, it's going to ask a question. What's the first curve? Okay, so you just pick a point on the curve. What's the second curve? And you can see that I've changed. I went from this line to that one. All right, and then the next one, it wants to know what the what your guess is. So you put a guess. You put it close to that intersection. And then it'll tell you what that intersection value is, which is that x equals -4.5 when y is equal to 12. So one of your solutions, we know the y equals 12. So one of your solutions is that x equals negative 4/5, which it shows negative 9/2 and negative 4/5 are the same. You would have to do this again if you wanted to find the other intersection point over here, which should be at negative 1/2. So that's another way that you can check these graphically. On the second absolute value you see here, there's a x on the outside. It's not just equal to a number. So let's go ahead and solve. It is isolated, so we're going to set up our two cases. X plus 15 could equal the opposite of 2x minus 21, or x plus 15 could equal 2x minus 21. And now you're just going to go ahead and solve. So I went ahead and solved and I got x equals 2 and x equals 36. Now I'm going to check my solutions. So I checked both my solutions and found out x equals 2 is a strenuous solution, so it does not count. And then x equals 36 did work. So that's how you solve an absolute value equation. Now we will look at inequalities. The setup is the same. You still want to isolate it, so we're left with the absolute value of 2x minus 3 is less than 7. You have two cases. You have 2x minus 3. Now it's less than 7, so you could either have that it's less than 7, let's see, or we could do 2x minus 3. If it's less than 7, it could also be greater than negative 7. Okay? So then you go ahead and solve. So once I solved, I have x is less than 5 and x is greater than negative 2. If you graph this, you have negative 2 and 5, less than 5, greater than negative 2. Now it all depends on what type of problem this is. Is it an and or an or? Because the sign is less than, it's an and statement, and is an intersection, so what they share in common, they both have to be part of the solution, so all values between negative 2 and 5. So your final answer is x is greater than negative 2 and less than 5. Now in this one on the graphing calculator, what I did is I plugged in, I set it equal to 0, so I subtracted the 28 and then plugged that into the calculator. Now onto the left-hand side, you can actually change where the graph shades. Now if I set it equal to 0, it would be y is greater than. So if it's greater than, we want to shade above. So you can see that I have that line where it's above it. And so now when it graphs, you can see that it shades everything above it. And if you look, what are those values between? They should be between negative 2 and 5. And you can see that on the left-hand side it's negative 2, and on the right-hand side it's 5. So this might not work out exactly every single time. I mean, it should, but your values might not be as nice as this one. But you can check on your calculator, are you in between that range where the solution is being shaded in between those numbers or outside or wherever it might be. All right, on to the last example here. On this slide, go ahead and isolate the absolute value and solve and set up your two cases and see what you get. So I isolated it, got the absolute value of 3x plus 15 was greater than 3. It is greater than, so it is an or statement. Even though in the beginning it was less than, but once you isolated it, it became greater than, so you go with that inequality that's isolated. And then you go ahead and solve your two equations. So I have graphed them. I have x is greater than negative 4, and x is less than negative 6. Once again, it's important as to whether this is an and or an or statement. This one's an or statement, so an or statement means either one can be a solution. So it's okay that they're going away from each other. If this was an and, for example, they don't intersect, so it'd be a no solution. But on this one, it is an or statement, so we do get the solution, and we'll do interval notation. So all values that are greater than negative 6, or, I said that wrong, sorry, all values that are less than negative 6 or greater than negative 4. Those are your solutions. And on the very last example, I have an absolute value inequality that has a variable on the right-hand side, and we'll talk about how this might change things. But go ahead, set it up. It's isolated. Set it up into your two cases. You have 3x minus 3 could be less than 4x minus 11. Now, since it's not a number over there, it's a little bit harder to think about. That's why that's important to know what those steps are. But then, if it's less than 4x minus 11, then you can also have 3x minus 3 greater than the opposite of 4x minus 11. And then you can go ahead and solve both of those. Now, once I have solved it, I have x is greater than 8. And on the right-hand side, I have x is greater than 2. On the left-hand side, I did have to divide by a negative the way I set mine up, so I did have to flip the sign. It is an and statement because it's less than. And then when I go to graph it, I have x is greater than 8, but I also have x is greater than 2. So it doesn't look like your traditional and or where you have ands going towards each other and ors going away from each other. You're going to see a lot of this. So you have to pay attention. Is it an or is it an and? And is an intersection. So they have to share the solutions in common. So we only want the values that are greater than 8. Those are the ones that satisfy both inequalities there. And that is it for absolute value, equations and inequalities.